Section 10.3, the quadratic formula. In section 4.6, we talked about solving quadratic equations by factoring. Section 10.3 talks about solving the same types of equations, but solving them by using a formula known as the quadratic formula. Before starting though, let's do a quick review of what we had talked about in section 4.6. If you remember, a quadratic equation is an equation that's written in the form ax squared plus bx plus c is equal to 0. In this particular equation, a, b, and c are all integers, or all just numbers, positive, negative numbers, except a cannot equal 0. So this is what the quadratic equation is. And we worked with quadratic equations back in 4.6. Back then, you were given a problem similar to this. X squared plus 5x plus 6 is equal to 0. And you were asked to solve that for x. What we had talked about back in section 4.6 is that in order to do this, the equation needs to be factored because I can't get an x all by itself on one side because my x terms are not exactly the same. One is x squared, one is just an x. So you go through and we're going to factor this and we're going to set them equal to 0. So in order to factor this, I'm going to have an x and an x as my first terms in both sets of parentheses. I'm going to be able to put in addition signs because this is an addition sign and both signs have to be the same. And then if I put in a 2 and a 3, 2 times 3 is equal to 6. And then when I FOIL it, my middle terms together are going to equal that 5x. So factored form, I get x plus 2 times x plus 3 is equal to 0. Back then we had talked about the importance of making sure that this was equal to 0. It needs to be equal to 0 because either x plus 2 has to equal 0 or x plus 3 has to equal 0 in order to make the equation work. So if x plus 2 is equal to 0, that would mean x would have to equal negative 2. If x plus 3 is equal to 0, that would mean that x was equal to negative 3. So we have two different possible answers for the x, and if you remember, we always talked about you could put those back into the original equation that we were given, x squared plus 5x plus 6 equals 0, substitute negative 2 in for x, and go through, and you would get 0 for an answer, and substitute negative 3 in for x, and put it in, and you would get 0 for an answer, so it would work. Another way to get the same answer, though, is to use what is known as the quadratic formula. The quadratic formula is a formula that was developed by mathematicians using a process known as completing the square. We're not going to go through how they came up with the formula in this class, but we are going to use the formula to find an answer, the answer to the same problem that we just ended up doing to this particular problem a different way. In order to use the quadratic formula, notice that I have it in the blue box. It is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you'll notice that in this particular formula there is a b, there's an a, there's a c, and there's another a down here at the bottom, there's another b. Remember the quadratic equation that we had talked about, ax squared plus bx plus c is equal to 0, also has that a, that b, and that c. So when you have a particular equation and you want to solve it using the quadratic formula, what I'm going to do is I have to first of all identify what is my a, what is my b, and what is my c in this particular equation. The a is the number that comes right before the x squared. And in this case, I don't have a number, but there is an understood 1 there. So in this particular case, for this particular equation that I'm dealing with, A is equal to 1. B is the number that's right before the x. So my B is equal to 5. And C is the constant that I have, just the number by itself, so C is equal to 6. In order to go through now and solve this, I am just going to plug those numbers in for the A's, B's, and C's in that formula. So let me run through and do that. I know x is equal to, it says the opposite of b. Well, b is equal to 5, so the opposite of that is negative 5 plus or minus the square root of, I need b squared. Well, b is equal to 5, so 5 squared is 25. Subtract 4 times a is equal to 1, times c is equal to 6. All over 2a. A is equal to 1, so 2 times 1 is equal to 2. So now I know that x is equal to the opposite of 5 plus or minus the square root of 25 minus 4 times 1 times 6 all over 2. And now I just need to solve this. In order to solve this, I'm going to use order of operations. The very first thing I need to do is I need to figure out, well, what is what I am circling right now in red. So I have 25 subtract, and I'm going to multiply 4 times 1 times 6. 4 times 1 times 6 gives me 24. So right now what I have is I have negative 5, I'm going to recopy what I have, plus or minus the square root of, and I have 25 minus 24. So that's just equal to 1. So I'm just going to put a 1 underneath that square root symbol, all over 2. And that's what x is equal to. Now I just need to go through and I need to solve this. I know that the square root of 1 is equal to 1. So I really have negative 5 plus or minus 1 all over 2. And now I'm just going to go through and solve this. If it's negative 5 plus 1, negative 5 plus 1 gives me a negative 4. Negative 4 over 2 gives me a negative 2. So one of the answers that I have is a negative 2. If it's negative 5 minus 1, negative 5 minus 1 gives me a negative 6. So I have negative 6 over 2, which is equal to a negative 3. So my two answers are negative 2 and negative 3, which are the exact same answers I got when I went through and I factored it earlier. So the quadratic formula is just another way to go through and solve quadratic equations. You just need to memorize this particular formula, the quadratic formula, and be able to apply it. So let's go through another example. Here I have x squared plus 2x subtract 15 is equal to 0. The very first thing to do is to identify what's the a, what's my b, and what's my c. So a is the number that comes before the x squared. There's an understood 1 there. B is the number that's in front of just the x, so that's equal to 2. C is the constant, and the operation sign that comes before it tells me what type of number that is. So in this case, C is a negative 15. Now I'm just going to go through and I'm going to use the formula that I have up at the top in the red, and I'm going to plug in the numbers. So I have x is equal to the opposite of b, which would be negative 2, plus or minus the square root of b squared. B is equal to 2, so that's equal to 4. Subtract 4 times a is equal to 1, times c, which is a negative 15. All over 2a is equal to 1, so that's all over 2. The very next thing I'm going to do is I am just going to go through and I'm going to simplify what is underneath this square root sign. And I'll tell you, this is where people tend to make the biggest mistake. In order to do this, I want to first of all just figure out, well, what are these three numbers multiplied together? 4 times 1 gives me 4, times a negative 15 gives me a negative 60. So what I have is I have all of this, what I'm going to circle in green, is equal to a negative 60. I'm going to put that up here at the top just for a moment. And now I'm going to rewrite really what I have. So what I have is I have x is equal to negative 2 plus or minus the square root of 4 subtract negative 60. Remember, everything in the green was equal to negative 60. I kept the subtraction sign that was here the same. I put the subtraction sign in there again, and it's all over 2. So now, when I continue to simplify, I have negative 2 plus or minus, and I have 4 subtract a negative 60, which is equal to 64. And that is all underneath the square root, all over 2. So I have negative 2 plus or minus the square root of 64 over 2. I recopied what I had because I was starting to run out of room. So at this point I have x is equal to what I have in the blue. And now I just want to go through and I want to simplify this all the way. So I have x is equal to negative 2 plus or minus. The square root of 64 is equal to 8. So I have 8 over 2. And now I just need to go through and figure out what this answer is. If it's negative 2 plus 8, negative 2 plus 8 gives me a positive 6, and I have 6 divided by 2, so one of my possible answers is 3. If it's negative 2 subtract 8, negative 2 subtract 8 gives me a negative 10, so I have negative 10 over 2, which gives me a negative 5. So I have two possible answers for this problem. Either x could be equal to 3 or x could be equal to negative 5. Here's another example that's a little bit different. 4x squared plus 5x is equal to 6. Remember, in the quadratic equation, it needs to be equal to 0. So the very first thing I would do for this is I would rewrite this, and I am going to get a 0 on this right-hand side by subtracting 6 from both sides. When I do that, I get 4x squared plus 5x subtract 6 is equal to 0 because I would have subtracted 6 from both sides. So now I need to identify my a, my b, and my c. My a is equal to 4. My b is equal to 5, and my c is equal to negative 6. This might be a spot where you might want to turn this off, run through and do this on your own first, and then turn it back on again and follow through and see if you do it the same way that I am doing it. Okay, so I have my a, my b, and my c, and I'm just going to plug in that information. So I have x is equal to, I need the opposite of b. B is equal to 5, so it's negative 5 plus or minus the square root of, I need b squared. B is equal to 5, so that's 25 subtract 4 times a is equal to 4, times c is equal to a negative 6, all over 2a. A is equal to 4, so on the bottom, I get an 8. Now I need to go through and I need to start simplifying. And once again, when I simplify, I'm just going to take a look at this area right now to start with. So I'm going to rewrite what I do have. I have x is equal to negative 5 plus or minus the square root of 25 subtract, and then I need to multiply the 4 times the 4 times a negative 6. When I do all that multiplication, that's equal to a negative 96. So I have 25 subtract negative 96 still underneath the square root sign, all over 8. As I continue to simplify this, I'm going to have x is equal to negative 5 plus or minus the square root of. And now I need to figure out, well, what is 25 subtract negative 96? I'm going to add them both together. I'm going to get 121 over 8. So here's what I ended up with. I just went to another page because I was running out of room. And now I just need to know, well, what is the square root of 121? That's equal to 11. So now I have x is equal to negative 5 plus or minus 11 over 8. And now I'm just going to do both of those operations. If it's negative 5 plus 11, negative 5 plus 11 gives me 6. So it is 6/8. And in lowest terms, 6/8 would be 3/4. So that's one of the possibilities. If it is negative 5 subtract 11, negative 5 subtract 11 gives me a negative 16. So I get negative 16 over 8, which is equal to a negative 2. So the answers that hopefully you came up with are x could either equal 3/4 or x could equal negative 2. I want to point out two other ideas that you will see as you're doing your homework, and here's an example. 3x squared subtract 2x plus 1 is equal to 0. You can see I've already identified the a, the b, and the c to the right-hand side, so I'm just going to go through the formula. X is equal to the opposite of b. B is equal to negative 2, so I'm going to have 2 plus or minus the square root of b squared. B is equal to negative 2. B squared then is 4. Subtract 4 times a, which is equal to 3, times 1, because it's times c, all over 2a. A is equal to 3, so it's all over 6. As I continue to work through this now, I'm going to have x is equal to 2 plus or minus, and I need to do the square root. I need to figure out what this is. 4 times 3 is 12 times 1, so I get 4 subtract 12 all over 6. As I continue then to work through this, I'm going to have x is equal to 2 plus or minus the square root of, and now I have 4 subtract 12. 4 subtract 12 is a negative 8. So I get a negative 8, and it's all over 6. Well, it's not possible to have a negative number underneath the square root. So, in this particular case, there is no answer for this that satisfies this particular equation under the real number system. So, we will just say that there is no solution. And once again, the reason for that is because the value underneath the square root, when I simplify it, is a negative number. Here's the last example I want to talk to you about in this video. X squared subtract 5x plus 2 is equal to 0. So going through the quadratic formula, I know that x is going to equal the opposite of b. B is equal to a negative 5, so I have 5 plus or minus b squared, which would be 25, subtract 4 times a is 1, times c. C is equal to 2, all over 2a. A is equal to 1, so it's all over 2. As I continue to work through this, I get x is equal to 5 plus or minus the square root of, and now I need to figure out, well, what's 4 times 1 times 2? That's equal to 8. So I have 25 subtract 8 all over 2. As I continue to work through this, I then have x is equal to 5 plus or minus the square root of 25 minus 8 is equal to 17 all over 2. This is the first problem that I've done in which when I went through and have done this, this is not a perfect square, the square root of 17. So in this particular case, I'm just going to leave it as 5 plus or minus the square root of 17 over 2 because there's nothing else that I can do with that. If it would have been possible to take this number and simplify the square root, I would have done that, similar to what we did in the last section, but in this particular case, I can't do that, and my final answer is 5 plus or minus the square root of 17 over 2. As you can see, being able to use the quadratic formula to solve quadratic equations is a very important skill. If you have any questions as you are working through the concepts, please let me know.